We start with terms we need to know the definition of. And again, I would spend a lot of time on this because the concepts are a little bit abstract and it's hard to put your hands around it. So you do need to spend some time knowing what the definitions are, but also how they relate with each other. Things you need to know. What the role of the compiler is. Well, let's talk about that. What the compiler does is it takes your source code that you write and translates it into something called Java bytecode. And it's this code that's run by the virtual machine. So the compiler generates code that runs on different CPUs or different platforms. The other thing you need to remember from chapter 1 is that Java's main benefit is its portability. Portability means you can run it on a PC and you can pick it up and move it to a Mac and it works, and you pick it up and move it to a Linux box and it works. Okay? So when asked about why people choose Java, that's the main reason. So Java programs can run without any change for the different platforms. The file extension for Java source code file, basically the name of the Java file, ends in whatever your class name is, myclass.java, Java. That's what a file extension is okay, what is the purpose of a semicolon in Java language? The answer is it shows you where the end of the statement is. Lines in Java program can span multiple lines. And because of that, the compiler needs to know when the statement is done. So you can put code that belongs all together on multiple lines. That's okay, as long as you put a semicolon at the end. So what's the purpose of a semicolon? To terminate a statement. Might be the best way to say that. Okay, in Java, what do you do most of the time? And that's you call methods on an object. So an object has methods. You call those methods or you execute those methods on that object. You do that all the time. What's the syntax for calling a method? Well, it's real simple. You just state the method's name. Of course, you need to, let's go back there. Let's make this a little bit more clear. You state the name and then you send in a parameter of what to print. In this case, it would just print out a blank line if we did it like that. So it's not that hard. If you want to call a method, just state its name. Put parentheses in to show that it's a method call. If there's any parameters that need to go in that method, make sure those are inside the parentheses. What symbol identifies the characters in a string? That would be quotation marks, double quotes around a string. String is just a series of letters. Also know that Java is case sensitive, so an uppercase dog is different from a lowercase dog. Those are two different names. So when I talk about spelling, you spelled your method wrong. It's probably due to capitalization, not so much spelling. You need to know that, this is odd, it's unique to Java, is that the name of the public class in the file has to match the name of the file name that the class lives inside. Typically with file names, they're not case sensitive, but when you talk about Java, since Java is case sensitive, then the file names are as well. So just realize if you rename a file that has a Java class in it, you also have to rename the class. So what is the Java library? Now, I found this isn't very helpful, but so here's the Java libraries. You can see they're quite extensive. Look at all the different packages that are available. So these aren't classes, these are packages. And there's a multitude of them. And so in case you want to do, let's just pick one out here. Java.util. This is where you have a lot of utility functions. This looks like mainly generic programming. Here are the classes that have been created in this package. So the Java library is quite vast, and it's in addition to the Java language. Like the Java language is only like 45 words, where the Java library is all these great classes. If you need to do timing, how do you work that? How to translate from one time zone to the next. All these really cool things that you don't have to code yourself. You can actually use whatever's in the Java library. So that's the Java library. Here's some more definitions. These are from chapter 2. What's the definition of a variable, an identifier, an accessor and mutator, an API, and a package? So definitions, there's a lot of definitions in chapter 2. Know the purpose of these data types? We have double, which stores real numbers that have a decimal point and things to the right of the decimal point. That's called a double. Then there's an int, which stores whole numbers, both positive, negative, and 0. And then string, which stores letters, a series of characters. You'll need to know how to declare them. Declare means tell the compiler that, hey, this is an int, and this is what I want to call it. Now, all through the Java language, there's these items called identifiers. And that's a really general term for very specific things. And an identifier can be a class name. Method names are identifiers. Variable names are identifiers. An identifier just identifies or gives the name of something in Java. The rules about identifiers are consistent across all those things: the class name, the method, the variable. They all have this requirement when it comes to naming stuff. Now, variables typically start with a lowercase letter, and then every subsequent word starts with an uppercase letter. I call that camel case because it looks like a camel. Looks like humps on the back of a camel. You start with a lowercase letter, but then again, every word after that is capitalized, and there's no spaces are allowed inside an identifier. Class names are typically named starting with a capital letter. Class names are about the only thing in Java that start with a capital letter, typically. What's the name of this operator? See the one in quotes there? That's the assignment operator. Notice I didn't say the equals operator. No, I call it the assignment operator because it takes the value on the right and assigns it to the thing on the left. So that's how you change it, is use an assignment statement. Let me bring that up so we can get an example of that. Here is, you're declaring a variable x and you're assigning it the number 5. So that's an assignment statement. This is how you declare it. This is how you assign it. If you want to do it in 2 different steps, you could do it like this. So the declaration and the assignment are done on 2 separate lines. But if you want to save some time, and most people say, yeah, I want to save time, they can do the assignment and the declaration at the same time. So again, that's how you declare and give an initial value to a variable. So the definition of a method is a sequence of instructions that accesses the data of an object. Not just accesses. It would be better to say manipulates. It does stuff with the data that's hidden inside. Okay? Now, if a method returns a value, that's called the return value. And I think we use this, where do we use this? I guess in our get method for our rectangle component. Guess we're in there right now. We had this concept of box color. So here's the drawing color, call it box color. And we got that from, oh, it's right there. Say we want to get the box color so that we can use it inside the test class for the rectangle component. So we created this method called getBoxColor. Notice right here that there's a data type right there. That means that getBoxColor is going to return the value of the reference to color. If you see void here, that means it doesn't return anything. Or if you see a data type here, it tells you what kind of thing it returns. So this is the return value of the method getBoxColor. This one, setBoxColor, doesn't have a return value. So you can think of it as returning nothing or void. So that's what I mean when I'm talking about that. So what's the keyword used to create an object? And also this question, what's the syntax of a call to a constructor? Let's look at that. Okay, so here in the tester, or the viewer, I guess, here's a good example of a constructor syntax. I have this object called component, and I want to make a new rectangle component and assign that to the component variable. So what I say is the name of the class, the name of the object that you come up with, so that's something you come up with, equals new, and the keyword right there is new. When you see that, that should give you a red flag that says, hey, this is a constructor, because it's calling the new method, which is a constructor. So this is the class name, but this is the name of the constructor. Now notice that the class name and the name of the constructor are the same, except for these two parentheses. You see that up here too with JFrame. Here you have JFrame, which is our class name. Frame is what we're calling it, equals new. That means call the constructor called JFrame that has the two parentheses. If we look at rectangle component, you can see that rectangle component inside of it, it's all hidden actually. So we know the syntax, that's on one of your syntax cards, which I'm going to hand back today. Okay, what's the purpose of an import statement? Okay, let's look at that. Here up at the top, you see all these import statements. And what you're trying to tell the compiler is these are the type of classes I'm going to be using in this program. It's telling me that we don't use containers, so I can get rid of that. But here's all the other things used inside this method or this class. There's this class called color. There's a class called graphics. Graphics 2D. We use the rectangle class that comes with the Java library. We use the random class that comes in java.util, that one library we were looking at earlier. If these weren't here, we'd have to write all these things. We'd have to create all these classes. Luckily, we don't have to do that because of the vastness of the Java library. We just rely on those methods, and we put them here scattered through our code, whatever we want to do. So that's what the import statements are for, so you can reuse classes that are defined either in other places in your project or come from the Java library. Finally, you need to know the purpose of a test class. Now, with every class that we write, we seem to have to write a viewer or a tester for that class. They're two different things. If you were writing Java code, you wouldn't include the test classes in with that product. You would only include the actual classes that do work. Test classes are for programmers to kind of exercise their classes. But in the real world, once you finally release it to the customer, there is no test classes. I guess the test is the actual functioning system. Know that an object reference refers to an object's location in memory. So objects are a little bit different than just standard types like int and double. For int and double store the value directly. Remember, object references says this is a reference to an object up in memory. So it's like, I don't want to use the word pointer, but that's the only one I can think of. Pointer has a very specific meaning in C++, and it's very confusing. But what you can think of is object reference as a pointer to an object somewhere in memory. So you have this one level of indirection. I think I drew that on the board a couple times. And then this is the one that's probably the hardest concept to grasp in this chapter. Is assigning one object to another creates two object references that refer to the same location in memory. So you can have two references. They might be pointing at the same spot in memory, and typically that's not what you want. So you have to take special procedures to get two different separate objects. So I would review that in the chapter. They do it better in the chapter than I'm doing it now. So maybe rely on your book for that one. All right. So that's everything that's going to be on the test. I recognize this is kind of a challenge, but I think by going through this and talking about each of the concepts, and better yet, using these concepts when we're coding, that helps you cement in your brain all these terms that we need to get an understanding of. Programming is very strange. and new for a lot of people. And you have to think a certain way, very logically, and realize even what you're trying to do. Describing what programming is difficult. The best way I can describe it is programming is trying to tell the computer how to do or how to solve the problem. And in order to do that, you have to have a pretty clear understanding in your head of, now what would I do to solve this problem? Well, I'd get a piece of paper out and I'd write all these equations on it. Well, that's what you're trying to do, is you're telling the computer, or you're trying to teach the computer how to think like you do. If you go looking at problems very methodically and pulling it apart, then your program is going to do that as well. If your brain is scatterbrained and you don't really understand, well, I've got this problem, but I'm not really quite sure how to solve it. You got to get that figured out before you start coding. Because if you don't understand how to solve the problem, the computer's never going to be able to do that. What are we doing when we program a computer? We're trying to get the computer to think like we do.